Good morning, friends. Myself Savan from Embedded System Science Department, VIT. So today we are going to see the introduction of LabView. That is a software platform for virtual instrument engineering. Let's see what is LabView. First, the name LabView stands for Laboratory Virtual Instrument Engineering Workbench. It is a powerful and versatile analysis instrument software for measurement and automation purpose. Here we have we know about different platform in software, like we have C language, C++ language, assembly language, different language. Here these all are a text language, but here LabView is a graphical programming language. Here all the things we are doing, all the code we are written, this is in a form of a graphical. That's why it is called a graphical programming language. Program are called virtual instruments. Like we have an extension of a .vi, .c, .asm and all different things. Here in LabView, our old programs have extension of a .vi. .vi stands for virtual instruments. Because of their appearance and operation imitate visible instruments. LabView contains a set of VI's function of acquiring, analysis and displaying, storing data. That is the main use of LabView. So whenever we are talking about any system, any hardware, basically it is divided in main three parts. Three parts is needed for any system. That is a test, measurement and control. These three parameters can be divided into three main components, that is acquire, analyze and present the data. These three are the major component of LabView, you can see. And when you are talking about real time, so any system needs some kind of system like a DEC, IMAC, any real time PLCs. These all are for using data manipulation, data acquiring, data analysis, data representation. All the things can be done by LabView software. Before you are going on a physical implementation, virtual test is the most important parameter here we are talking about in LabView. The main function of LabView is doing all the hardware implementation on a virtual basis to save our time, to save money, to make efficient work. To help you analysis your data, LabView includes analysis function for differential equation optimization, curve fitting, calculation. In short, many mathematical operations can be done also here. Here, ExpressVI are specifically designed for measurement analysis, including filtering and spectral analysis, as well as mathematical manipulation, all the data expression. We can go for signal processing here for such purpose like filtering, windowing, transforms, detection, harmonic analytics, spectrum analysis. Such kind of things all are provided here in LabView. Next thing, LabView include the following tools to help in presenting data on the basis of graphs, charts, tables. You can say 3D controlling it, 2D, 1D. All the work can be easily done here. As well as over the internet, web publishing tools, data sockets, TCP/IP, VI servers. All the things we can do, are available to present the data. Now let's see about the advantages of a LabView. First thing is a GUI. Any system, any software you develop, any hardware you implement, the main important part is a GUI. That is the user interface with the user. So here the main important is the GUI, and we are having a graphical language. That's why graphical language make more very efficient way for a user. So whenever any user is doing a programming in LabView, so the GUI seems very good. So first advantage is GUI, very good design, professional use, the drag and drop user interface. There is another advantage here, thousands of built-in functions, IP analysis, IO. These all are in terms of palettes here. What is the palette and all things we will see later. Modular designing and hierarchy design. That is actually labview VI. It is it can be in terms of sub VI also. So that is advantage also. Modular designing is there. Multiple high-level development tools. Develop for faster development purpose with any specific application. Yeah, standalone device. labview gives more flexibility. Then professional development tool. We have many professional development tools. That is this all part reaching when we doing actual programming. Small demo I can see. Here it's kind of try to spreadsheet directly, whatever the output is directly stored in the spreadsheet, read from spreadsheet kind of your Excel sheet, anything, such kind of higher operation you can do. That's why this is one of advantage. Okay, then multi-platform. The majority of a computer system use the .labview. Work on platform like Microsoft Windows, Mac OS, Sun Solaris. All the operating system can support labview. labview actually reduce the cost and preserve the investment. A single computer equipped with labview is used for countless application and purpose. It is versatile product. Yes, it is versatile product in terms of as I said. Any system, if you go to implement and then correct it on a basis of a trial, it will take your much time, much cost, and you are wasting your energy. Such software as a labview gives so much flexibility in terms of saving this all time. First, you have to implement all your system on a software like a labview. Then and then, if all the things are correct, then you can easily go and implement on a hardware level. Flexibility and scalability, as I said, this ensures that application can easily integrate new technology in future. Connectivity and instrument control. labview has read-to-use library for data acquisition and devices, motion control, and vision products. This I2 and RS2, these are the PLCs. All the things can be easily supported here as a peripheral to the labview software. So it gives more flexibility. Next is the open environment. labview provides this virtual software, versatile use the software, provide open development environment. This is a free tool. That's why we all use versatile. This open environment in terms of this open environment takes advantage of existing code. Any code can easily be integrated with the system. Software with the .NET, ActiveX, DLL, LibreCache, TCP, Web Service, XML, anything. So this is one more advantage. Next is the distributed development. It can be easily develop a distributed application with a labview. Like powerful server technology, server technology, you can afford process intensive routing to other machine for faster execution or controller remote monitoring and the control application. Nowadays, kind of IoT or something is just these are the things are just vastly developed for remote controlling purposes. So such kind of thing also here you can easily do it. Next we will see rapid development with the express technology. Using IO assist and configuration based express VI, we will see what is the express VI, but right now just configuration VI in the IO assist. It provides rapid use of the all software. Rapid create a common measurement application without programming by using this labview software signal application also. Then next is the compiled language for faster execution. Compiler and compilation part is most important in any software. So here labview is a compiled language that generate optimized code with execution speed comparable to like a different C and any high performance code. So compared to that, it is really easy and faster for execution purpose. That we will see when we do some code. It is really useful advantages. The next is a simple application distribution. Using the labview application builder to create executable and share library for any development. Next is target management. Any kind of device will be targeted here, like a different microprocessor, microcontrollers, PDA, PLCs, and all this things. Especially here, one term is the real-time embedded devices. So it is the main advantage of labview, you can consider. Then it's an object-oriented design. Yes, you can say it's an object-oriented device by programming structure to by its programming language specifically, which actually encapsulate the means to create modular and extensive code that's also we see in programming. Algorithm design. Algorithm design in terms of developing algorithm using a math-oriented textual program. When we debug it, it's a .m file script syntax with a labview script. Labview script provide many vast, or we can say many mathematical expressions in a depth. So that is also advantage for us. By this last point, we end of the advantages. Now let's see what is the software environment here. Here, basically, 3 steps are there for creating our application in labview software environment. First is the design user interface. Second is the draw graphical codes and run our program. Actually, I want to explain it by comparing it our any other code language like C or assembly. If you consider, then first we create a flowchart and simply understand what we actually need to implement by code. So that part here is the design user interface in terms of all cycle. The next is the draw graphical code here. In that other language we just type a text and it is somewhat bulky and lengthy process. Here is the draw graphical code in terms of any function what you need. You have to just take graphical palettes and put it here on a software. Build the design with the interface part with each other, and last is the run our program. Very simple. Virtual instrument has 3 main components. One is the front panel, second is the block diagram, third is the icon and character panel. That thing I want to demonstrate you right now. This is my front panel. Here, actually, this front panel is used to check the output after compiling your code. As well as you can add many palettes here. Such kind of these are the palettes. You can see different palettes. What are there? We'll see that. And the next part is a block diagram. This is a block diagram. Here we will see which kind of graphical code we are designing actually. And you can see third is icon and connector palettes. In both you will see different icon and connector palettes here. Both with the different functionality in both you will see. In front panel also this all are different. In block diagram also different. This all is better. Next is in labview you build a user interface for front panel with control and indicator that already I told. Controls are we have many controls here. Push button, styles, and other input device and the indicator. These are the controls. And for output indication, we have indicators like graphs, LEDs, and other displays. Import the panel, you can see the connecting panel is here in corner. That provides the actual insert this kind of code design. You have. You can see from there. Next, we'll go for what is it from front panel and block diagram which display more in detail. Let's see, we have different control like knobs, tools, dials and other input devices. For indication purpose we have graphs and LEDs and chart and other display devices. The front panel is the user interface of virtual instrument. The code is built using graphical representation of functions to control the front panel objects. Same code is seen with development. The block diagram contains this graphical source code. You can add code using VR and structures to control the front panel objects. In front panel, whatever we have output as per the design in our block diagram, we can see. Next also like how front panel is an interactive user interface. Whatever GUI we have see there, so it's an interactive with the user. It means the front panel because it stimulates the front panel of the physical instrument. That's why it's called a front panel. One of the most powerful features of the labview design is to virtual instruments by creating graphical user interface on the screen, like how that operates the instrumentation program, control selected hardware, analyze the required data, and display results. These are the parameters we need everywhere, and these are the powerful features of this labview software. This is our front panel. Here you can see you can easily see whether the output is there. I'll start from here. The pull down menus. Pull down menus we have different file with the different functionality. The next edit is here, new projects, output, tools, windows and help. There's another software here. As per the requirement of labview, these are the pull down menus. Next is the panel palettes. Panel palettes have different icon button you can see here. The functionality of icon button is also custom-rated. Here next is controls. This button, up and down button you can see here, these are the controls. And these are the constants. And here is purpose of indication. You can see here nothing, the value is fixed constant. Here using this button you can change the value of the output data. Such kind of free label like this output is R for simple adding motions, so any kind of label you can use. Boolean switch is there. It's a down switch, push switch you have inside. Many various switch are there. But you see something you can include no possibilities that as we discussed there. Controls are introduced to stimulate instrument input devices and supply data to block diagram of VR, and indicators are outputs display used to simulate the instrument output devices and display data. The block diagram requires or generate whatever the required generated by block diagram. The front panel is customized to emulate control panels of a traditional instrument. Create custom test panel, but it is usually present to control operation of process. The next is the block diagram. The front panel can include knobs, push button, graphs, various other controls, and indicator also. But controls are introduced to simulate instrument, input device, and supply data to block diagram of VR. Indicators are output display used to simulate instrument output device and display data to diagram requirement channel. Already said that. After front panel, the main part is completely built. Code are added using graphical representation of function in the block diagram. As I said, what was designed here is code whatever we design. It is always in a block diagram section. The block diagram contains the program for front panel, and it contains the graphical source code composed of nodes, terminals, and wires. The program is actually executable program. Wires, how the wires is functioning, that we'll see in the diagram. If you want to connect any two pellet, small wire is needed to provide a path between two objects, two pellets, and we carry a data from one place to this place. This is the wire. Look at the object includes terminals, subwire, functions, mounting, and structures, and wires are reaching. Terminals are what is the entry and exit port, that is the extend the information between the panel and the diagram. This is the block diagram. Here palette is there, different palette is there. What are these palette? We see by function and these are the program unit you can see here. How to give control to terminals, we see any control terminal is the input part of any palette, and after manipulating using this palette, we have indicated terminals which serves as the output, and actual output we can see on a control. Then various loop structure is there. You can use for loop, while loop, or any other loop. And the wire, as I seen you shown in like that wire which provides a path which carries the data, and from one port to another. Next is a node. This is a node which manipulates some data and to analyze directly. Then Google switch, different kind of switch with different purposes of use, different purposes of use we can use here. Next we will see icon characters. Use VI as a sub VI, it must have icon and character panel. Actually sub VI and VI card we will see when you have a code. In other text language you have one particular code. This code are executed number of times. So what you will do, you make one function, and whenever you need it oftenly, you just call to that function. Such kind of thing is happening here. No need to draw a bulky circuit again and same time number of times. So we just create a sub VI. That sub VI is a small icon used with the input and output, and then no need to draw the programming code, graphical code number of times. That is a sub VI. It connected panel shows us the inside circuit of the sub VI. This whole thing we will see in next part. Now front panel toolbar. So this all things we will see on software. Now we will see what are the front panel toolbar. These are the icons we will see on front panel, and what is the functionality or what is this icon is for, we will see one by one. First is the run button. Run button is just to run a single time. The solid white arrow is the indication. If you want to use a continuously running mode, then this is the button, run continuously button. The same execution of the code is running continuously after continuously time. Then when you press the run continuously button, your run button is becoming like solid arrow with black color. So this is appearance of after running it. This indicates your program is in a continuation mode. So if the VI that is running is a sub VI, then run button will appear like that. Then if your code has some errors, this button is to display the error list window. And when you press on this button, all the errors you can see, as well as warning also. This is the about execution button. When you come out from the continuous mode, you have to press this button. This is the pause button to pause the running gear. This is the text setting button to change the font size, style, and all the things we are doing in Word, Microsoft Word. You can do it from here also. This is the align object. To align the object along the axis, in terms of axis, including vertical, horizontal, top edge, left edge, right edge, and all things. This is a distribution object. To space object evenly, including the gaps in compression. This button will show functionally when we do our coding. Because when we do our coding, it's a graphical, so we put many space in between different pellets. This all things can be evenly distributed by this distribution object. Resize object to resize multiple front panels object to the same size. We are doing this button. This is a recorder when we have objects that overlap each other, so it will help at the time. Select one of the object in such a scenario with the position tool, and then select from move forward, move backward, move front, as well as move back. This is a show context help window. It's a help window, you could say. Any kind of help you need it. This is a type to remind you that a new value is available to replace an old value. This is the indicator. Then in block diagram, this is the important icon we have. That is a highlight execution button. And this is a written wire button. In highlight execution button, we can see each and every value of our execution, means from input to which input is come on a wire. We can see which value are carrying on the pellets. Also we can see which values are manipulating. At the output of the pellet, I have gotten what value is coming with the manipulation. After the pellet, what are the output is going on the next part, and on indication what it will. So for continuous mode, different value are changing at that time. In my loop, in my number of iteration, in particular iteration, which value is going on. This button is helpful for such information. This is a written wire to save the wire values at each point, any point you can see. Inflow of execution, so that when you place a probe on wire, you can immediately retain the most recent value of data that pass through that wire. So it is also one of the important functions. And this is a setup intro to open a node and pause. When you click on this button, executes the first section and pauses at the next section of a severe structure. You also can press Control and down arrow. This is socket, and single stepping through VI step to the VI node by node. This is a step into the same as that. To open node and pause, when you click on step into it again, it executes the first action and pause at the next action of the subview. Here you can say it executes the first action as a step into your next button is a step out. You can even allow the functionality by pressing the control plus up arrow keys. By stepping out of a node, you can complete a single stepping through the node and navigate to the next node. So this is a step out function. And to finish the execution of current node, whatever it is, step out is used. Step over to execute a node and pause the next node. and shortcut is step control plus right arrow. By stepping over the node, you execute the node without stepping through the node. That's it. And last one is a warning. It appears if VI includes warning, and you place the check mark in your show warning, you can see the whatever the error you have. Warning, it's kind of indicate there is a potential problem with the block diagram, so it will be used to troubleshoot it. Then property dialog box. Front object have a property dialog box that you can use to change look or behavior of a front panel, as well as by right clicking on front panel objects. Select the properties from the shortcut menu to access the property dialog box, and then the option is available on the property dialog box for an object are similar to the options available on the shortcut menu of the object. When you select any palette, any node from the palette list, just right click on it and go to the property. Here I do it for that node function. So node property is here. You can see you can change the height, width, and the disable option is there. The data type, data entry, and scaling the option is there. Format you can change. You can change the text level. Such kind of functionality you can do it. Then pull down menus of front panel and block diagram. First is the file. Pull down the file menu, which contain the command pull down menus. First is a file. File actually contains the command common to many applications such as print, edit, load. Next is the edit. It has some universal command like undo, cut, copy, paste, and everything. We'll see when we do code. Operate. The user can run or stop the program from the operate menu. The user can also change the VI default values, control print, and look at the compilation features, switch between run mode and edit mode. Then next is tool. Tools, the menu allows the user to access the built-in and add-on tools and utility that work with the labview, such as Wizard and Automation Explorer, where tech devices are configured, or the web publishing tool is used for creating HTML page from the labview software itself. The next is a browse. It contains a feature for simple navigation among large number of VIs. The user can have view VI hierarchies and all the things. Determine VI entire submenu and view the written breakpoint and all. This all the things are covered in browse. Next is a window. Tile both window. Switch between open VIs. So the error list and all the things are different windows are shown here. And here tile both the window in terms of front panel and block diagram. Then next is the controls and indicator. Next we will see data for programming and G programming. What are they? Labview follows a data flow model for running years. Block diagram node executes when all inputs are available, all outputs are available, execution nodes are there. At that time we can execute our code. When a node completes the execution, it supplies the data to its output terminal, passing the output data to the next file in data flow file. How this will working we will see in next slide. Visual Basic, C++, Java, and most other programming language follow control flows model of the programming execution. So here you can see easily number 1 and number 2 in both figure A and B are the input controls. Plus or minus sign here. You can see these are our nodes. These are our function of addition and subtraction respectively. Here I have fixed a float constant value that is of 50.00. So this is my constant, numeric constant you can say, and it's a floating value. Here this block is named as a random generator. It generates the number of randomly data. So two different functions applying here. We take two numeric input from user, add it, and this output of addition is applied as the one of input of a subtractor here. Other input is a constant here, but in the second figure, same operation of this plus sign addition function is happening, and the output of this addition is applied as one of the input of the subtractor, and the second input is the random generated data, and we have result as indicator of result and result code. This indicates the output of the subtractor sign. This case for the RAM is from left to right. Always operation is start from left and one by one execution is ended at the right corner. Now G programming. The programming language used in learning called G programming. G stands for graphical. It is a visually oriented approach to programming. Like in a C language, assembly language, Java, we have to type different syntax in terms of text. This is a text language, text programming language. It is a graphical language. We have a number of icons, graphical icons. These are the functioning icons. So that's why it's called a graphical language. Since this might be a case for multiple nodes simultaneously, G is inherent capable of parallel execution. The graphical approach also allows non-programmers to build programs by simply dragging and dropping virtual representation of a lab equipment with which they are already familiar. In laboratory, we have different equipment like oscilloscope and function generator and many others. Here, when we go to the lab, this all are you can see in terms of a small icon. You have to just drag and drop this icon and easily work with that, and the whole physical implementation you can see in laboratory, this all can be happen virtually with a small icon and this function and all things in learning software. This is the advantage of the learning. Now you can see the comparison between text-based programming and graphical programming. Here we have more syntax first and more oriented thing for any programming. This is syntax. Here syntax is a knowledge, but it is not required for the program. In terms of icons, icon itself your knowledge in actual means of that any icon is a function. You know how to function our system, our hardware, and this function itself is your syntax. If I suppose one example is that I know that for one experiment I need a oscilloscope, I need a function generator, I need two different controller IC. So here this knowledge of knowing such thing I needed, this knowledge is my syntax. Like I need oscilloscope, so directly I will go and find the oscilloscope. I need function generator, I will go and find function generator icon. I need addition operation, I need adder, full adder, half adder, any logical, boolean, any mathematical functions you need, you have to just find the icon and execute it. So this is the first comparable advantage of a graphical programming. Second is the execution of a program is from top to bottom. Here is left to right. Listen. To check for an error, the program has to be compiled and executed. Here errors are indicated as a wire, as we wire the block. Where whenever the error is there, this block will blinking, or we can say indicating option is there. Semicolon design needs extra coding or needs extra work. The front panel design is a part of program. Without it, we cannot sort or analyze the output. The next text-based program is a non-interactive. Here is a highly interactive in terms of GUI. This is a text-based programming where the programming is a conventional method. Here is a data flow programming is there. In a flow pattern, whole program is executed. Logical error finding is easy in large program. Logical error finding in a large program is quite complicated here due to number of blocks with a bunch of wires or something it's even complicated. Programming flow is not visible. The data flow is clearly visible with also we have flexibility of to get which path is staying which kind of data. It's a text-based programming. We have icon-based programming and while passing parameter to subroutine is difficult. Here is very easy by using subroutine. So these are the comparison between text-based and graphical programming. Now different data types we have. Data types indicate what objects, inputs, outputs you can wire together in the system that we need. For example, if a node has orange border, you can wire any input with an orange level. However, you can wire orange node to input with a green level. Green color is here specifically used when we use some boolean function. Orange is something when you communicate with the numerical data. Blue is something for iteration mathematical purpose. This all we see when we actually design our code. You can see numerical floating from orange color is there. So integer iteration part will be indicated by blue color. Boolean is a green color. Somebody we can keep we can elastic and so kind of some slight difference is there. Instead of single string indicates that same color. So different color is there here. For the path we have different there. Dark green over here. For reference we have dark green color is there. The cluster purpose cluster different color is there. But brown is major orange color is there. For reference this one again brown color is there. Often the conversion convert the dynamic data expressed here can be used to convert the dynamic data type to numeric boolean form, array data type, anything. When we convert from dynamic data expression here is based on the block diagram, the configure from dynamic data box appears. Then next is the representation and precision. Here we are represent various types of byte and some byte, word and some word, long and some long, single precision, double precision, extended precision, complex single, complex double, complex extended. Byte size also you can see as a 8-bit called a byte. It's a 1 byte operation, whether it's a sign or unsending number, it's a 1 byte operation. The word contains 2 byte, long contains 4 byte, 8 byte. With respect to this data, different types, here byte is also different. And these are the applications we see in our level software. These are the operating systems of our locally. Here some sockets I want to use. We have different pull down menus and file. So file has software is there. Majorly can we use this control save, control S for save or for control open or close. We use the control O and W respectively. For use we are using control N. Then for after if some wire is broken, so control B to remove broken wires is there. So it will remove all broken wire. Control Z allows you to trigger the light, and control Z for only undo operation. So undo until you are needed. Then for run your VI, you need control R. For abort operation, control Z. So you have tools to control Y to edit the VI revision history if needed. Then window operation control G. Whenever you just press the control, press on a blank VI from your labview software, first thing we are doing is the control G. To tiling the block diagram in control window. So it is the first operation we are doing for showing it properly. Then you need any help menu. So control H is there. Other shortcut is there. Control A to over the comment if needed. In library we are having from the survey part we will see in programming virtually. So it will be easy to understand. This PPT is prepared by one of my professor, Prakash sir. So thank you for preparing it. Thank you very much all.